The spark plasma sintering system is one of the most advanced sintering systems in the world today. It is a novel rapid sintering technology that utilizes pulse current and axial pressure applied between two electrodes to intensify powder sintering. It possesses distinct characteristics such as fast heating rate, short sintering time, controllable microstructure, energy saving, and environmental friendliness. It can be used to prepare metal materials, ceramic materials, composite materials, as well as normal bulk materials, amorphous bulk materials, gradient materials, etc. Furthermore, the SPS equipment also provides possibilities for the manufacturing of every special new materials, such as sintering normal materials, functional gradient materials, composite materials, tungsten carbide, silicon nitride, silicon carbide, or other hard materials, structural ceramics, and functional ceramics, all without significant gain growth. The SPS equipment primarily consists of a furnace body, furnace door, furnace frame, vacuum system, gas filling device, temperature measurement system, pressurization system, water cooling system, DC power supply, pneumatic device, and electrical control system. The operation panel mainly includes the login interface, main screen interface, temperature interface, data interface, alarm record interface, recipe interface, seating interface, and customer service interface. Ensure that the purity of SiC powder meets the requirements, typically more than or equal 99%, and the particle size is generally in the nanosecond 50 to 500 nm or semi-core scale 0.5 to 5 depending on the target performance. Selection of sintering aids at sintering aids such as B4C, AL203, Y203 to reduce the sintering temperature or improve the compactness. Mixing powder. Load the properly proportioned SiC powder into a mixing machine and mix for 4 to 8 hours, applicable to batch production. Weaving accurately weave the required amount of powder based on the mold size and the target sample size. Selection of mold. SPS typically utilize high-strength graphite molds, resistant to high temperatures and pressures, with the inner walls of the mold coated with graphite paper prevent the sample from adhering to the mold. Cleaning the mold. Ensure that the mold surface is free of residue. It can be wiped with ethanol and left to air dry. Mold assembly. Assemble the graphite mold, upper and lower pressure bars, and graphite paper, ensuring tightness and alignment. Confirm that the vacuum system, cooling water system, power system, and the pressure system are operating normally. Check whether the contact between the electrode and the graphite mold is good to avoid uneven current distribution. Calibration of instruments, ensuring the accuracy of temperature measurement, usually through infrared, thermometer, thermoscopes, and pressure control systems. Filling the waved SiC powder evenly into the graphite mold and gently vibrate to ensure even distribution of the powder. Apply slight pressure, 3 to 5 palma, to the powder in the mold using a manual or hydraulic press to initially compact the powder. Be careful to avoid excessive compaction, lest it affects the gas releasing during the subsequent sintering process. Place a sample mold in the sintering chamber of SPS furnace with upper and lower electrodes aligned with the mold pressing rod. Close the sintering chamber, start the vacuum pump, and evacuate to a high vacuum of less than 10 Pa to reduce oxidation and gas interference. The SPS sintering parameters needed to be optimized based on the characteristics of the SiC powder and the target parameters. The following are typical parameter ranges. Temperature 1800 to 2200 degree. Silicon carbide SiC typically requires a high temperature sintering depending on whether additives are added. Heating rate 50 to 200 degree per minute. Rapid heating is a characteristic of SPS, but excessive speed should be avoided to prevent mold cracking. Holding time 5 to 30 minutes, depending on the sample size and density requirements. Pressure 30 to 40 pama, usually applied at the beginning of temperature rise and gradually increased to the set value. Pulse current, DC pulse, typical pulse period is 2 to 25 ms. Specific duration depends on the equipment. Atmosphere, protected by vacuum or inert gas, such as AR and 2, to prevent oxidation. Turn on the power and apply a pulse current, causing the powder in the mold to start heating rapidly. Apply axial pressure, simultaneously gradually increasing the pressure to the set value. Monitor temperature, pressure, current changes in the real time. Pay attention to the mold displacement, as changes in displacement can reflect the densification process of the powder. After sintering is completed, turn off the heating power supply. Maintain the pressure or slowly release the pressure. Allow the sample to cool naturally to room temperature within the mold, typically in a vacuum or inert atmosphere, to prevent cracking caused by thermal stress. Open the sintering chamber. Remove the mold, disassemble it, and then take out the sintered SiC sample. Be careful when removing graphite paper or surface residue. Use a sandpaper or diamond gradient disc to polish the sample surface to remove any possible carbonized or mobile marks. Density. Measure the density of the sample and calculate the compactness theoretical density to 3.21 gram per cubic centimeter. When operating the SPS furnace, it is necessary to wear protective equipment to avoid risks posed by high temperatures and high pressures. Ensure the cooling water system operates normally to prevent equipment overheating. Avoid excessive pressure or temperature that may cause the graphite mold to crack. Regularly check the wear condition of the mold and replace it if necessary. For different combinations of SiC powder and additives, it is necessary to optimize the sintering parameters through experimentation to achieve the best density and performance. Excessively high temperature or pressure may lead to abnormal grain growth or sample cracking. Keep the powder and molds clean to avoid impurities affecting the sintering quality. The sintering chamber needs to be cleaned regularly to prevent contamination from residues.